In this video, I will discuss properties of liquid, condensations and vaporizations processes, explain about what is vapor pressure and what is boiling point, boiling process, and also discuss the relationship between intermolecular forces between liquid particles and vapor pressure and boiling point of a liquid. Hey, I'm Teacher Tang. If you like my videos, do remember to click on the subscribe button below so that you won't miss any notification as I update my channel. The first property that I'm going to share is liquid has definite volume but it takes the shape of the container. So why liquid take the shape of the container? This can be explained in terms of intermolecular forces, molecular arrangement and molecular motions of liquid. The intermolecular forces between liquid particles are strong, but it's not strong enough to hold the liquid particles at a fixed positions. Hence, liquid particles can still move past one another and causes the liquid to take the shape of the container. The second properties of liquid is liquid has significant surface tension. So what is surface tension? Surface tension basically is the tendency of the liquid surfaces to shrink to minimum surface area as possible. How can the liquid have significant surface tension? It is because there is a net inward forces acting at the surface of the liquid, which causes the surface of the liquid to behave as it is covered by a stretch membrane. Why liquid has significant surface tensions? In terms of intermolecular forces, molecular arrangements and molecular motions, in the interior of the liquid, intermolecular forces are acting at all directions. However, at the surface of the liquid, there is net inward force pulling the liquid particles at the surface of the liquid into the interior of the liquid. This causes the surface area at the surface of the liquid to be reduced, and the liquid particles at the surface of the liquid are more closely packed. This results in liquid has significant surface tension due to imbalance force at the surface of the liquid. The third properties that we are going to look at is viscosity. Some liquid is more viscous and some liquid is less viscous. So what is viscosity? Viscosity refers to the resistance for a liquid to flow freely. In terms of intermolecular forces, molecular arrangements and molecular motions, due to the stronger intermolecular forces, liquid particles will have higher resistance to flow. So when the liquid has higher resistance to flow, we say that the liquid has higher viscosity. However, at higher temperature, the liquid particles will have higher average kinetic energy. When the liquid particles has higher kinetic energy, they can overcome the intermolecular forces between them. When they can overcome the intermolecular forces between them, now the liquid can has lower resistance to flow. So when the liquid has lower resistance to flow, then the liquid is said to have lower viscosity. However, when the liquid has larger molecular size, the liquid will have stronger intermolecular forces. When the intermolecular forces are strong, then the resistance to flow in the liquid is high, and therefore the liquid will have higher viscosity. The fourth properties is compressibility. Liquid has higher compressibility than solid but lower compressibility than gas. Why? In terms of intermolecular forces, the intermolecular forces in liquid is strong enough to hold the liquid particles close together, but is not strong enough to hold the liquid particles at fixed positions. Because of that, liquid is more compressible than solid. And for liquid, there is only little free space between the particles, while in gas, there are a lot of free empty space between the particles. Because of that, liquid is less compressible than gas. The fifth property is diffusion. Liquid can diffuse faster than solid, but diffuse slower than gas. Why? Again, the intermolecular forces between liquid particles are strong enough to hold them close together, but not strong enough to hold them at the fixed positions. Because of this, liquid can diffuse faster than solid. And somewhat, between the liquid particles, there is only little empty space, while in gas, there are a lot of empty space between the gas particles. Because of this, liquid can diffuse slower than gas. So what is vaporization? Vaporization is a process whereby a substance changes its phase from liquid to gas. Vaporization occurs at any temperature below the boiling point of a substance and only occurs at the surface of the substance. In liquid state, the intermolecular forces are strong enough to hold the liquid particles close together, but is not strong enough to hold the liquid particles at the fixed positions. Hence, the liquid particles can still move past one another. As the temperature increases, the average kinetic energy of the liquid particles increases. At the surface of the liquid, some of the liquid particles can overcome the intermolecular forces and escape from the liquid surface and become gas. This is what's happening during vaporization. What is condensation? Condensation is a process where a substance changes its phase from gas back to liquid. In gaseous state, the intermolecular forces between gas particles are very weak, and the gas particles are very far apart from one another. However, when the temperature decreases, the average kinetic energy of gas particles decreases. Now the gas particles move slower. When some of the gas particles collide with the surface of liquid, gas particles could not overcome the intermolecular forces between them and therefore be trapped as part of the liquid. This is what's happening during condensation process. When a liquid is being put into a closed container, some of the liquid particles, especially at the surface of the liquid, could gain enough kinetic energy to overcome the intermolecular forces between the liquid particles and escape the liquid as the gas. And the gas could collide with liquid surface and exert a pressure. And that pressure exerted by the gas particles from the liquid is what we call as vapor pressure. So now shall we look at what is the definitions of vapor pressure. Vapor pressure is the pressure exerted by the vapor when the liquid and the vapor are in the dynamic equilibrium in a closed system. In the dynamic equilibrium of a closed system, the rate of vaporization is equal to the rate of condensation. Means that the rate of liquid particles convert to gas particles is equal to the rate of the gas particles convert back to liquid particles. What is boiling point? Boiling point is the temperature at which the vapor pressure of the liquid is equal to the external pressure acting on the surface of the liquid. What is normal boiling point? Normal boiling point is the temperature at which the vapor pressure of the liquid is equal to the external pressure of 1 atm. Boiling is a process where a substance changes its phase from liquid to gas. Different from vaporization process, boiling process not only occurs at the surface of the liquid, but also within the liquid. In liquid, intermolecular forces are strong enough to hold the liquid particles together, but not strong enough to hold them at a fixed positions. Hence, liquid particles can still move past one another. As temperature increases, the liquid particles gain kinetic energy and move faster. As they move faster, some of them can overcome the intermolecular forces and escape from the liquid, become gas. During boiling, gas or vapor are also formed within the liquid. That's why you can see small bubbles form in the liquid. However, due to high external pressure, the gas or vapor particles within the liquid cannot escape from the liquid. As temperature increases, more gas bubbles are formed within the liquid. So as more gas bubbles form within the liquid, we can say that the vapor pressure of the liquid increase with the increase in temperature. The vapor pressure within the liquid will continue to increase until it's equal to the external pressure. When the vapor pressure within the liquid is equal to the external pressure, then the boiling point is reached. At this point, the gas particles within the liquid gain enough kinetic energy not only to overcome the intermolecular forces between them, but also to be able to overcome the external pressure and can therefore escape from the liquid and become gas. At a given temperature, the liquid with stronger intermolecular forces will have lower vapor pressure. Why? Here are the two liquids, liquid A and liquid B. Can you tell me which liquid has stronger intermolecular forces? Yes, the answer is liquid A. Why? It is because at same temperature 50 degrees Celsius, liquid A has higher vapor pressure. When liquid A has higher vapor pressure, basically means that at 50 degrees Celsius, more liquid particles of A has enough kinetic energy to overcome the intermolecular forces and then escape from the surface of the liquid and become gas particles. In terms of graph, how do we know which liquid has higher vapor pressure? Again, the same principle holds. The liquid which has stronger intermolecular forces will have lower vapor pressure at a given temperature. For example, in this graph, we have three liquids: diethyl ether, ethanol, and water. So among these three liquids, which liquid has stronger intermolecular forces? Yes, water has stronger intermolecular forces. Why? It is because at 20 degrees Celsius, can you see that the vapor pressure of water is the lowest, which is about 25 torr. While for ethanol, at 20 degrees Celsius, the vapor pressure is about 50 torr. For diethyl ether, at 20 degrees Celsius, it has highest vapor pressure, which is about 450 torr. Because of this, water can be concluded to have stronger intermolecular forces because at same temperature 20 degrees, water has the lowest vapor pressure. Previously, I have discussed at a given temperature, the liquid with stronger intermolecular forces between the liquid particles will have lower vapor pressure. So how does this affect the boiling point of a liquid? In fact, if a liquid has stronger intermolecular forces between the particles, it will have lower vapor pressure and therefore more heat energy is required to increase the vapor pressure of the liquid up to the external pressure. Because more heat energy is needed to increase the vapor pressure of the liquid during boiling, hence the liquid will have higher boiling point. In terms of graph, how do we know which liquid has higher boiling point. Again, the same principle holds. The liquid with stronger intermolecular forces will have lower pressure at a particular temperature. Hence, more heat energy is required to increase the vapor pressure of the liquid up to the external pressure. Hence, the liquid will have higher boiling point. For example, the three liquids, diethyl ether, ethanol, and water, at 20 degrees Celsius, water has lowest vapor pressure. Hence, water has strongest intermolecular forces between the particles. Hence, more heat energy is needed to increase the vapor pressure of water up to the external pressure. Hence, among these three liquids, we will expect water to have the highest boiling point, which is equal to 100 degrees Celsius, while ethanol boils at 78.3 degrees Celsius and diethyl ether boils at 34.6 degrees Celsius.